Assalamualaikum and very good morning. Can you open your Putra Blast and sign your attendance now? Bismillahirrahmanirrahim. Assalamualaikum and a very good morning. For Muslim, can we start with Kitab Al-Fatiha? Just to remind you, okay, for those who just enter this room, can you log on to your Putra Blast and uh, sign your attendance? Okay, so this is I think our third class or for the chapter one, right? So I hope that we can finish chapter one today. Okay, so we have already learned about software quality model, five software quality model that we already discussed, right? So we have McCall. First one we have McCall, and the second one we have Bohm, and we have HP Verbs. We have ISO 9126, and the last one we have 25010. This is the latest one. Okay, this is the thing that uh, I think more towards something that discussion between the academia or the one who will work in the university, the researcher, and also some practitioner. It's not all, right? So sometimes we are a bit doubt, right? Is it all the company in the software development company follow this quality standard or not, right? So sometimes we just, oh, okay, if I join the company, they will something like follow this quality quality models, right? So sometimes, yeah, because most probably most of you don't have any experience in working in the industry. So we want to know what is uh, the practice in mod sorry in quality regarding to the quality model. Oh, sorry, guys. I need to record this. Allow me to record the session. Okay. So we already visit five, right? And then we want to see whether what is happening or what the industry do with this model, quality model. So I got or I have an information here. This research is conducted by So this research is about the software quality models in practice, a survey result, right? This is not my research. So this is research done by someone in Germany. So if you can see it here, we have uh, again. I just want to highlight we have learned uh, about Bohm's model. We have learned about McCall's model, Ferb's model, ISO 9126. We have 25010. We have some other Dromi also. There's a lot of software quality models outside. So what have what call that the company, is it adopt all or focus on one or two, or what they are they use for their quality model. So this uh, research have been done to see the software quality model in practice. So if you can see it here, okay, so this is the objective of this one. This is just want to see the main class of quality models, the quality assurance techniques that they use, and then to identify the problem that related to this model, and covers some company. They have some big size companies, small size companies, in several domains, right, to allow a broad view of software product quality. Okay, so the context is in Germany, right? Their partner is Capgemini. Is quite in Europe. Capgemini is one of a big company for software development. Fraunhofer, I test tried SAP. So I think you know SAP, right? Uh, Software, a big company software. Siemens, right? Siemens of Germany, and then I think it is conducted by the research conducted by Technische Universität München or TU Munich. Okay, so this is the usage of quality in practice, right? Company specific is the largest one. This is not percentage. This is the survey, the amount of company that use company specific quality models. They have their own quality models. They are not referring, probably they refer, but they are not fully use something like yeah, McCall. They use only McCall. They focus only Bohm, or they focus on the HP, or some other quality. They have their own specific, right? Then if you are entering a company later when you go to the labor market, when you are working with the company, please don't say that, okay, do you have any quality model? What quality model that you use? What is the what do you call that, the reference for you to 5010 or 9126 and so on. So a lot of company, they have their own company specific models, quality models, because it is based on the context, based on their context, and based on their experience. Based on their experience, probably at first they try to adopt 9126, or they will try to adopt one or two, and then after that they improve just to suit for their company purposes, right? Because some company is just for banking, some company develop for a payment gateway, some company normally focus on military, so they try to adapt, or they try to take some of probably the quality characteristic in order to just to suit for their needs, right? It's not all, right? It's not all the eight in 25010, the security functionality, blah 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 blah, and then they are not taking all the things, right? And another one is quality gates, right? They have milestone and quality gates, checking here and there. They have some milestone, and then they have a quality gate. Some people have, right? It's not some, for me it's quite a big number, right? Defect class base. Remember that we mentioned, we have learned before that quality mean less bugs or zero defect, right? So this some company have used defect classification. If less defect, then it is a quality, right? So this a quality product. So this is the one that they use. So if you can see it here, only 35 companies refer to 9126, ISO 9126, right? The one that we have learned before. And then domain specific, they have, yeah, as I mentioned to you before, they have some domain. Probably they only focus on one or two domains, and then after that, they try to suit all the characteristics for that domain, right? So some laws, right? Some regulation, probably something like law for health application and so on. So they have some law, and this is a CMMI process, ISO 9001, ISO 2500, sorry, 25,000. So this is we will learn later on the software quality process, right? So this is the thing that other, yeah, related to growth and also others, and some of that don't have any. So there is possibility that when you enter company, they don't have any quality model in their company, right? So this is just to share with you, right? We learn something, but the one that we learn is something that is crucial, right? Because when we go to the company specific, then if they thought talk about the characteristic, then we know, okay, characteristic, is it characteristic this, and this taxonomy? Then you may discuss with them, right? And then, but I just want to remind you again that if you're entering the company and then you don't see any quality models that you have learned before, they don't use that, then please don't say that they don't have any quality models at all. So probably they have something in their mind, and then you have to ask them, and then you have to table, because they don't document it, right? They are probably in the mind of their software architect, or in the mind of the software development manager and so on. Okay, so this is just to show to you that even though we have some standard, but standard is just a guideline, and then it is not forcing you to comply to all or to follow all of the guideline. It is probably can be suited for your needs, right? The one that what you want focus for, right? Just to highlight something, right? So wide variety of quality model use. So we found that almost all participants use some kind of quality model. They have something like that, right? The quality model. A variety of this model is employed in practice. So ranges from laws in the international standard to domain specific or company specific, right? So company specific models are widely used, right? So we know that 70% of the respondents saying that they use company specific. They have their own specific quality model. 70%, and 9126, the one that we learned, the one that we discussed, is only 28%, right? So this is, I cannot say that the whole world something like this, because the survey is in Germany, right? In German company. So most of the German company don't use the 9126, right? Probably it's different in Malaysia, right? Probably because Malaysia sometimes we use we don't develop by ourselves, and then we just follow some of the guidelines that available in the market. That is ISO 9126 or 25010. Okay. Quality models typically are adapted, right? 87% adapts their use of quality models, right? So, and then the ISO standard, yeah, is not well accepted in this survey. So you can see that in only 28%, right? So quality model user are moderately satisfied with their model, and aggregation is done but not predominant. So I put this paper oops, I put this paper in your Putra Blast. You can just read it, right? It is not too lengthy. It's just something like a report. You can just read or scan it, right? So I think you have some view that you learn something, and then in practice sometimes they are not fully used. It's more towards adapt based on their environment, based on their needs, and based on the current situation or the context of the company. Okay. All right. So we continue with the software process quality. All right. So we have here software quality management, and software engineering process quality, right, have a direct bearing on the quality of product, right? Management and the process have the influence here in the software quality product or software product, right? So you cannot say that I want to just focus on product, not the process, right? This is something that interrelated, right? It's a really high correlation, meaning high relation, right? If you have a good process, you have a good management, then you can get a good software product. It's hard to see that you don't have any good process, you don't have any good management, but you produce a good product. That one is not really easy to find, right? Okay, models and criteria that evaluate the capability of software organization are primarily project organization and management consideration, right? So to evaluate the capability of software organization, so you have to see the organization and also the management consideration, right? It is not possible to completely distinguish process quality from product quality because process outcome include product. As I mentioned to you before, yeah, this is really high correlation. You cannot just you cannot differentiate. Okay, this is process quality, this is product quality, and then the process and the product it should be something aligned. It is not something that is different, right? So determining whether a process has the capability to consistently produce products of desired quality is not simple. All right. If you have a good process, right? If you have a good process and then you get a good product, a good product, uh, to maintain it, right? To consistently produce a product based on the process, it is not simple, right? You have to, it is not only you just what do you call that make a same process, then after, because you have to improve, right? You have to improve. Okay, this process, I have a this product, and then after that I have some defect, then another process you have to improve. Probably you have to improve the process, uh, add more quality gates and so on. So determining whether a process has the capability to consistently produce products of desired quality is not simple, because sometimes the product have also to suit the situation, the current situation, or the current practice and so on, right? So the software engineering process influences the quality characteristic of the software product, which in turn affect quality as perceived by the stakeholders. The same point that I've mentioned to you before. So software product quality. Software engineer must determine the real purpose of software, right? So stakeholder requirement are paramount, is the thing, the biggest thing, right? And they include quality requirement in additional to functional requirement. So quality requirement, right? It is not only functional requirement. The software should calculate, the software should do this, and this. And then when I click this button, the calculation should be something like this. This is more functional, right? Functional requirement. But what is the quality requirement is the performance. Okay, if I click this button, the response time should be less than 2 seconds. So this is the quality requirement embedded with the functional requirement, right? So you embed the quality requirement into the functional requirement. Let's say something that this function, this facility of registration of new user should the module should what call that should uh, sorry, the module can be used uh, for 2,000 people at one time. Uh, so the module, and then this is a quality requirement that you put something that mention about this is how many people in one time, right? Access the system in one time, right? Does the software engineers have a responsibility to elicit software quality requirement that may not be explicit at the outset, and to understand their importance as well as the level of difficulty in attaining them. So software engineers have the responsibility to elicit quality requirement. So normally, if you do the requirement engineering, right, you go go for interview, you go for workshop and discuss with the stakeholder, they normally think about uh, functionality because they are function expert, right? They are features expert. They want to have they want to have this. They want to have this, and this. And then the software engineer, based on the experience of software engineer, okay, this is the something like this function. This function is more towards calculation. Is it the calculation is, yeah, mediumly, example, medium, it is not really complicated, so the system should respond in this specific of time. This is based on the experience of the software engineer, because he need to ask this the uh, what do you call that, the stakeholder or the user, what is the quality characteristic for that function. So they have to dig. They have to ask. It is not something that, okay, you want to have this? Yes. You want this? Okay, I can record this. But you have to give more questions. Okay, you want to have this function. This function is just listing all the application in a day, or in 1 week. So what if I click this one? You want to have the full detail of this application. So is it okay if it is in 2 seconds or 1 second, or normally what you should have? Sorry, the response time of this. Yeah, you cannot. He or she, the stakeholder, cannot say that. Oh, I want to just in the blink of eye. Oh, no. You can bargain with them. Oh, if this one, I think around maybe 1 second. Is it okay? Then okay, the quality requirement is performance is 1 second. So you have to think, right, based on the quality characteristic that we we what do you call that, we learned, or we discussed before. For another example, is something like, okay, so the user can use mobile phone, or can user have to use only laptop, or they can use it both. Okay, this is one of the quality requirement that we want to ask about compatibility, right? Compatibility or portability of the system. Okay, so all software development process, eliciting requirement, designing, constructing, improving quality are designed with these quality requirements in mind, and may carry additional development costs if attributes such as safety, security, and dependability are important. So for every uh, what phases, you have to have your quality in mind, right? So when you are developing the software, like you do the design of the software, you do the coding of the software, you have to think about maintainability. Is it the code that I written is easy to maintain or not, right? So, but this is something like may carry development costs, but you have to ask them, okay, this if this quality is not in place, then you will face some this problem later or something like that. So this is something that you need to know, right? So as this is from the software engineer's perspective, you need to have uh, quality in your mind, that the one that you develop, the one that you elicit the requirement and so on, it should be quality in place, right? You should embed quality in all phases of your software development. Right. So software product quality again. Next. So additional development costs help to ensure that quality obtained can be traded off against the anticipated benefit. Right. You can discuss with the customer. If you give, or if you invest with this cost for the quality, you can get what, right? You can normally we can show them something like the ROI, or return on investment on of quality. So the term work product means any artifact that is the outcome of the process. So if we talk about work product, so you have to be in your mind. Work product means any artifact, any artifact, the one that I mentioned to you, artifact, any of the deliverable of the software development. Is it the documentation of specification? Is the source code? Anything, right? So, for example, right, subsystem specification, software requirement specification, and also software component design, source code, and so on. While some treatment of quality are described in terms of final software, sound engineering practice requires that intermediate work product relevant to quality to be evaluated throughout the software engineering process. All right, sound engineering practice meaning that you have you apply the software engineering practice, right? There's something like design, something construction. You have all these phases, right? Sound engineering practice, the engineering practice itself. Okay, software quality context. So software quality in context of the product and process. So you can have, this is a standard process, right? So you have procedure, more towards process and also the standard itself. And then you have a product, right? You have a software development process, two things, right? So product must meet the expectation of the user, right? And then for the process, here also conform to the requirement, right? So product need to have to conform to the requirement and also to meet the expectation of the user. And then all the written requirement must in the should comply to development process and develop according to sound engineering practice and standard. So this is something that the relation between the product, the process until the end of the uh, the development, right? Okay, so the quality of software product can be improved, all right, through preventive processes or iterative process of continual improvement, right? So quality product you can improve. You can see some product they have improved in what do you call that in release, right? So new release they have improved this, new release they have improved this. This is more towards the continual improvement, iterative process. It requires management control, right? So management have to control this, coordination, right? Feedback from many concurrent processes, right? That is the software lifecycle process, the fault, right? And also the quality improvement process. So you can get the information on or the feedback from the current process, that is from the software development lifecycle when we do the software development, when we construct it, and then we know that okay, we can improve this, and this, right? From the developers' opinion or from the developers' feedback. We can also have the feedback from the fault detection if we found bugs and so on. So we know that okay, next I have to eliminate this bug by introducing some process or some stages in order to eliminate this, right? And also the quality improvement process. Okay, so the theory and concept behind quality improvement, such as building a quality through the prevention, early detection, right, of defects, continual improvement, and stakeholder are pertinent to software engineering, right? Okay, these concepts are based on the work of expert in quality. Okay, so some approach in improving software process or software development is by using the Deming improvement cycle of plan, do, check, and act. Right, the PDCA cycle. Okay, so some other approach is using evolutionary delivery, something that the Japanese, the Kaizen, right? Improve, continuously improve the Kaizen, and the quality function deployment or QFD, right? So this is some technique that you can use to improve the quality, right? Do the quality improvement. So management support. This is more toward the management support, right? So because it to improve the quality, it takes a lot of resources, right? That and also some investment of money to achieve the goal. right? So this is the management need to know that, need to know the benefit of doing improvement of quality, and then they can give you, or they can support uh, the activity. Right. So this is the example of Deming PDCA. They have planned. So identify a problem, right? We know that from this we can have the three from this feedback, then we can have the problem that we face on the current development, and then after that we identify. You had to analyze the problem. What is opportunity? What is the possibility of the possibility to solve the problem, the alternative, and so on. So develop the hypothesis about what is the issue. What is the issue? Maybe you think about, okay, because we have problem with this button because A, B, and C, or because of this list is not really fast in giving appear in the GUI because of this and this. You have to make your own hypothesis and decide which one to test, right? And then you do it, right? Test the potential solution, ideally on small scale. First you try to do it, or probably you have a same problem in a lot of module in your development, and then after that, okay, I take one module, I try to solve it, and then try to see what and then try to measure the result. Okay, we try to, this is the solution, we try to use this module for the solution. So that one is do. And then after that, you do the check, right? Study the result, measure the effectiveness, decide whether the hypothesis is supported or not. Okay, the one that you think, okay, this is the problem and this is the solving the resolution of this is the way on how to solve this problem. And then you have do, and then you check, okay, yes, it is effective. When I use the software again, the problem is doesn't appear at all. So okay, then you think that, okay, if I put it in another module, what happened? It should be okay or not. Then if it is okay, if the solution is successful, and implement it. So put it in all the module. All right. So this is house of quality. So I think I just want to show you the picture here, right? This is on how people see quality and then make something like the house of quality. This is some what I call it, the way on how to define quality for them, what, how, and so on, right? Okay, we move to another one, right? This software safety. So safety critical system are those which system failure could harm uh, human life, other living things, physical structure, or the environment, right? So, for example, mass transit system, chemical manufacturing plant, medical devices. So, guys, what else? What other? Uh, if you see this definition, safety critical system, a system failure could harm human life, other living things, and physical structure of the environment. So, what are the example of this kind of system?
Air trafficking.
Air trafficking, that's good.
Um, is the sensor in the car sensor?
Sorry?
Uh, the car sensor whenever we parking the car.
Oh, the car sensor, yes. Uh, as a bigger scope, something like a vehicle, right? Car. Yes, Ayman?
Financial losses, doctor. Like if, for example, if a flight system fail, then it may lead to accident, and there will be harm in human life and harm into planes, and the planes are very expensive.
Mhm. Yeah, agree that. Yeah, the aviation system, right? The airplane system, the one that we know before, right? Is Boeing or Airbus? I think Boeing. Yes, Boeing 737 Max, right? the case that there's a system problem, and then the harm a lot of people, right? A lot of people died because of it. Okay, safety critical software can be categorized as direct or indirect. You have direct or indirect. So direct means that the software embedded in the safety critical system, such as flight control computer of an aircraft. So this is direct, right? So anything happen with the system, and then you can see it immediately that uh, the fail will harm people, right? Will have a really bad consequence to people use it or surrounding areas. Indirect, something that is not really direct, but they have some influence on the safety critical software. Uh, for example, software application use the indirect software for for example, is the software to test the environment, right? You have a software, automated software to test the airplane system. So this is indirect, right? If something happened with with the testing system, it's you cannot see that immediately, but after you run the system, after a while, then you will see that the system fail, or the failure have influenced the user, right? So safety critical system, we have a lot in Malaysia, right? We have some health what do you call that, medical system in hospital, that one is safety critical. If anything happen, or any wrong configuration, you will see that it will harm people's life, right? And then also some vehicle system, that one you can see that is safety critical system. Okay, next, three complementary techniques, right, to reduce the risk of failure is to avoid it, right? If you have a problem with safety, then you can try to make some program to avoid that one, and to detect and also removal, and also to limit the damage. All right. Okay. Uh, for example of try to reduce the risk, the avoidance, right? So example of avoidance is when you know that you can crash because of probably what do you call that, from obstacle or something, and then you try to avoid it, right? You try to avoid the problem, sorry, the obstacle, and then detection and removal. You detect the problem, and then you try to remove it, right? If something happened in the system, you try to detect self detection, and then after that you try to remove the problem from the system. And also the damage limitation, this is something like, if something happened in the car, let's say the braking system have a really problem, and then to limit the damage, and you try to set the car to be not driving more than 40 kilometers per hour, something like that. This is to limit the damage, right? Because of the problem with the braking system, something like that. Okay, this technique impacts software functional requirement, software performance requirement, and development process, because you have to think, right? In each function, you have to think about the safety of the function, right? And increasing level of risk imply increasing levels of software quality assurance and control techniques such as inspection. And higher risk levels may necessitate more thorough inspection of requirement design and code, or the use of more formal analytical techniques, right? So for this highly safety related, for cyber for safety critical system, uh, they have something like in car, they have something ISO 26262. This is more toward the software, the safety of the software that used in the car. So they have some regulation. They have something like a risk assessment before you. For every function, you have to have something like risk assessment. How risk is it? How and then they have some calculation on how to uh, to calculate the risk. Right. Normally, you have a risk of something like to 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 calculate the risk. Normally, you will have something like uh, what do you call that? Cause and effect, right? Frequency or something like this, right? But from a car point of view, they add controllability, right? Is it if something happen, is the driver can control it or not? So they have their own calculation of risk, and then after that they categorize their risk, and from that categorization, then you will determine how uh, how the test would be, how to test the function, right? For example, if it is something like an infotainment system, right? Infotainment system, the risk is not too high, so you can just do a normal checking, a normal testing, right, of the system, and not related to a lot of people, meaning that you can do it in your internal testing. But if it is braking system or handling system, this is related to people who are driving and also the surrounding area. You may hit people, you may hit anything in the road, right? Then they require you to do the thorough inspection. It is not inspected by the people inside the company. They have to hire some other people from the other company that do the inspection specifically to do inspection, and then they invite to the company and go through one by one all the program to make sure that the program do what it sorry, the program is programmed uh, in the safety manner and then in the correct way. So this is the safety part, right? They based on the risk, right? This is from my point of view, from my experience in automotive. So automotive more towards the risk, and then after that they determine how to conduct the test on how to inspect the quality of uh, the uh, car module. All right. Okay, guys. This is the last what call that the last slide for this chapter. So a failure once in a million years, only one failure, right? So common sense leads me to think that it is not software, this that software is really quality, less bug, no bugs, but I but actually I think that you have neglected some factors. Yeah? You're not testing some factors. That's why you say that it's no failure, right? You are not testing safety, you are not testing security or something like that, right? So this is the thing that you need to know, right? So the now it is something like I need you to open your eyes really broad about the quality of the system, right? It's not only process quality, sorry, it's not only a product quality, and it is not only a process quality. And the process and the product have an interrelation. And then when you look at the product, right, you not only to see the performance of the product or only functionality of the product. Some other things that you have to see or you have to take into account is something like security. Is it portable or not? It is maintainable or not from the perspective of the developer or the maintainer of the system. Is it testable? Is it flexible, modifiability, and so on. So I hope that I have opened your mind, right, on how to see a product or how to see a software in order to assess the quality of the software. So what we have learned this in chapter 1, right? So just want to summarize, okay? So we have already know about the basic concept, right? Definition of the quality, and also you'll be able to explain about the cost and also the impact of bad quality, right? So you know how to calculate it. So the concept here, and then we know that the quality is not something that you can just plug and play. You have to nurture it. You have to make it as a culture in your company. You have to train, right? Okay, so other thing you have we learn about what is the quality means, the quality itself, right? And then after that we go towards the definition of quality in software, and also the definition of software quality. Then we know how to do the value and also the cost of quality calculation, right? Remember this formula: the cost of non-conformance, bad one. The cost of conformance is the thing that you use to you do to prevent, or the thing that you invest, or the cost of prevention and also appraisal, and then you can get the total of quality cost of quality. Yeah. Then we learn about the quality models, right? The five models, two or three is a classic one, and then the more modern one is the 9126 and also the 25010. So we have learned that, and we have also learned about what the uh, the software quality model in practice, right? The one that I presented before. I need you to read it. I will give the paper in the Putra Blast. You can just read it. It is something that you need to know. Okay, you need to know, and you need to aware of it, right? And then we learn about software product quality, and also the relation of the software product and also the software process quality, right? And we have software quality improvement. This is one of the example by Deming, right? The PDCA, right? Plan, do, check, and also act. And we learn a bit on software safety, right? Safety critical, and how this is the safety. Normally, we use the safety mechanism or safety tactics. That is how to overcome this safety issue by avoidance, by detection and removal, and by limit the damage. Right? Okay, that's all for the chapter one. Do you have any questions so far, guys? Guys, do you have any
Uh,
question? Yes,
not
Haziq.
sure. No, I don't. No, I don't have it.
Okay, thank you.
Doctor, I have a question, but it's not about the. It's in general. Like
Okay.
you said in previous class, like there will be some things that are not in the slides. We have to focus in the lesson now, right?
Mm-hmm. Mm-hmm.
When we study, should we refer to a textbook to find them? So when we study for exams,
Yeah,
are
sure. Yes.
we should refer to textbook? Oh, okay.
Yes, you should. That's why I record the session, and
Ah,
that's why
okay, okay, okay.
I would like you to come to the class.
Yeah, sure.
Okay, guys. I'm planning to give you a small assignment, but not today. I will give on Friday, guys.
Oh yeah, yeah. Okay.
Okay, okay. Because
Okay.
we have two session, right? Sorry, we have two class. So this is your group one and another group two. So when I finish the group two, and then after that, I will give you a small assignment, right? This is individual assignment, a simple one,
Yes, sir.
and I will give you around probably 4 days to do that. I think it's not a big task. Okay, and then we have how many people we have now? We have 30 in the classroom, right? So I would like you to get groups. groups in four, right? Four people in a group, and probably two of your group have three people, right? Because we have 30, right? So we have 30. If it is four, then you have 24. Another six will have three people in the group. So two group will have three person. Can you form a group and then email me the your group members, guys?
Okay.
Okay,
Is that
doctor.
Okay, sir.
Okay, right?
alright?
Any more questions,
Uh,
guys?
Doctor, I want to ask about healthy competition.
Yep.
Actually, it is kita kena buat pasal apa?
Oh, okay. Kita you have to do okay. Ooh, healthy because they have every year they have the team, right? A team meaning that a topic that you have to work on. So you have to propose meaning a technique on how to solve the problem, right? So the problem now in this year is something like a remote work or collaborative work. So you have to propose something in order to solve a problem in collaborative work, right? Something like if you have a what do you call that? You have a because in construction, normally the engineer need to come, right? Need to come to do inspection of the worker, right? The worker if they are doing right or not, and then probably you have to monitor all the cranes and so on. So this should this what call that needs people to be present in the construction sites. For example, if you want to have something like okay, I want to make it remotely, meaning that install some cameras and then do some detection, right? So person detection, how many person in the construction site, and then since it's COVID-19, we don't want probably uh, the we don't want the worker to work closely, right? So they have to remain 1 meter away from each other. Then we can we can propose okay, this is the solution. Put the camera and then we have detection of distance and so on. So this is something that the one they need, right? It's just something like a proposal, but the proposal needs something like a good backup, meaning that this can be done. It is not something a proposal that uh, what call it? It's not practical, right? It should be something like simple and it's practical.
So it's actually not producing a software, right?
No, no, no. It's not. It's not really producing a software. You can have something like prototype, but the prototype is not a really, really what call that a finished product. It's just a prototype, something that you can you can make a video of or this is probably this is the process of the one the solution that you propose.
Okay, doctor.
Mhm. So just let me know if you want to participate. Then we can discuss it later. Okay, guys. Just to remind you again, please sign your attendance in Putra Blast. Right? Don't forget about it. Right? Inshallah, we will see you next week. And please check your Putra Blast on Friday. And I also will give you information in the WhatsApp when the assignment, the small assignment, is already in the Putra Blast. Okay, thank you very much. I hope that you can stay safe, right?
Okay, sir. Thank you.
Thank you.
Thank you, sir.
Welcome.
Thank you, doctor.
Thank you, Doctor.
Welcome.
Doktor.
Yep.
Grup ni doktor suruh buat untuk projek ke apa?
Ya, untuk projek nantilah.
Projek ni ada sambungan daripada yang software architecture ke ataupun software design ke?
Oh, tak ada.
Tak ada
Itu buat
sambungan
baru.
lah.
Tak ada
Buat
sambungan.
baru lah.
Buat baru.
Okay.
Okay.
Alright. Thank you, doktor.
Welcome.